So the next section that we need to cover, in the last section for this chapter, with some exceptions of just kind of combining them, is hyperbolas. Again, kind of one of those shapes that, again, is made by taking kind of that cross section, kind of that vertical cross section of two cones that are put together. And we're going to be able to do two things with it, just like we've been done with the other shapes. We want to be able to graph it if it's in standard form. And then we want to be able to have it in conic form and put it in standard form by completing the square. So pieces of the hyperbola that you need to know and understand. By definition, it's a set of all points P such that the difference of the distances from P to two fixed points, or the foci. So we've got foci, just like we've had before. They're kind of the purple ones inside of there. Those are our focus. Notice that the focus is notice where the focus is located. It's located on what's called the transverse axis, which the transverse axis is essentially the longer of the two axes that we're going to use when we draw these. It's going to be the way that they kind of open. And we'll talk about the equations in a little bit. But those are the two foci of that. The line drawn through the foci that intersects at 2 points is called the vertices. So these 2 points, this green line, the green ones there and there, those are called the vertices. And we're going to work on finding, obviously, we're going to find those vertices as well. The foci and the vertices, like I said, along the transverse axes. The conjugate axis is the one perpendicular to the vertical, and we're going to actually find co-vertices for this as well to kind of help us draw it. And then the transverse that passes through the center of the hyperbola, and that center point is, again, the point we're going to use to help us draw it. So we're going to find the center. We're going to find the vertices. We're going to find what we'll call the co-vertices, and we're going to find those focus, that C value as well. The other thing that we're going to find in here is the asymptote lines. Remember, we've talked about asymptote lines quite a bit, and talked about asymptote lines are lines that things approach but never intersect with. So those blue lines here and here, those are our asymptote lines. So our graph, when we're making these graphs, are going to get closer and closer to those asymptote lines, but they're never really going to hit them. Okay, so if you need a little bit more time, go ahead and press pause to write these different things down. You're going to see it in the next slide as well. Okay, so there are two different ways that we can have hyperbolas. We can either have a horizontal hyperbola or a vertical hyperbola, and the equations that we use differ depending on which direction that they go. So we've talked about kind of standard form for hyperbolas, and they've got it written down there. We're going to change it up just a little bit to get it more into the mode that we've done it. We've always said it's x minus h squared over a squared. Instead of just saying x and y, it's the same thing, but now it's minus y squared over b squared is equal to 1. Oops, I should write it how I wanted to write it, like I said I was going to write it. So it's just y minus k squared over b squared is equal to 1. Okay, and this is kind of a horizontal one, so it's going to open if x comes first. Now, because there's a minus symbol in between them, this is what's going to make things a little bit different. So if that x comes first, you're going to kind of have that x thing going out. Okay, it kind of looks like an x if it comes together. For a vertical one, okay, so vertical one's going to go kind of that up and down. We're just going to kind of turn it around. And for the vertical one, it's going to be y minus k squared minus x minus h squared. And then that's over a squared, and that's over b squared, and that's equal to 1. Now, in this case, it very much matters which direction this goes, because the y is going to come first, and your x is going to be the minus. So when y comes first and it's minus, it looks like a y. When x comes first, it looks like an x. The center for both of these is always going to be that hk value. Okay, center is always going to be hk. Center for this one is going to be hk as well, but again, you've got to be careful when you're doing the center of this one, of the vertical one, because remember, y's go with y's and x's go with x's. So it's y minus k, so we need to make sure that we put that in the k value and the x value for that. The other thing that we're going to talk about, the vertices, and again, the vertices are just A and B, just like before. The co-vertices are going to be, B. And then we've got our C value, that's our focus. And that C value is found a little bit different. The C value, and actually this is actually the Pythagorean theorem. So C squared is equal to A squared plus B squared. So in an ellipse, C squared was equal to A squared minus B squared. In a hyperbola, C is equal to A squared plus B squared. You kind of got that right triangle piece going on with that. So again, if you need a little bit more time to do this, to write these down. Oops, I guess I forgot to talk about the asymptote lines. Those asymptote lines, we do want to have a formula for those asymptote lines. So those asymptote lines, if it's vertical, it's y is equal to b plus or minus b over a times x. And that's if it's a horizontal one, if it looks like an x. And the equation for the asymptote lines, if it looks like a y, is plus or minus a over b times x. And it's about slope. It's what it is. And we can find actually those, if you mess them up, if you can't remember which one's which, if it's b over a or a over b, it's just slope. Y equals mx plus b. So we can put those different things in there that we need to put in there with these. Okay, so let's look at a couple of examples. Again, if you had to press pause, go back and press pause. Go ahead and press pause with that. All right, so this first one, we're given the equation. We're going to find the center. We're going to find the vertices, which go along the transverse axes. We're going to kind of co-vertices, which go along the conjugate axes. And then we're going to find that C value at least. And we're actually going to graph this and show you how we're going to graph it. So first we have to identify that it's an ellipse. And we can tell that it's an ellipse because of the minus sign in between and the fact that it's being divided by something. Okay, so that right there tells us it's an ellipse. So we can go ahead and find the center point. So we're going to find the center. Center is pretty straightforward in this one. There's nothing being added, so it's just 0, 0. So I'm going to go ahead and put a dot at 0, 0. Okay. Now we're going to find our two axes. So the y comes first, so we know this is going to look like a y. So the y is going to be, so this is going to be a vertical one. Okay, so it's going to be this one right here. So we've got a vertical one here. So my a squared is underneath my y value. And again, so a squared is equal to 4. So a is equal to 2. Again, the way I think about it is my a value, my y, since the a is underneath my y, the 4 is underneath my y value is changing by 2. So it's going to go there, and it's going to go there. Okay, so those are my vertices for this one. My b squared value is 16. So my b value is plus or minus 4. I'll make those in green. So that means my x value is going by 4 this time. And we're going from the center point again. So they're going to go there and there. Now, it doesn't matter that the co-vertices, the conjugate axes is large. It doesn't matter in these cases. It is what it is. You just have to remember that if it's underneath the x value, it goes with the x value. If it's underneath the y value, it goes with the y value. Okay? Since we're in here, we're just going to find the c value as well. So c squared is going to equal a squared plus b squared. So 4 plus 16. So c squared equals 20. So c is equal to plus or minus the square root of 20, which is 2 radical 5. Okay? And now that focus point is going to go this direction. It's going to go along the y this time because we've got that vertical going. And it's going to be outside of my vertices because we're opening up and we're opening down. So from that center point, you're 2 times the square root of 5. So approximately, just for demonstration purposes for this first one, that's about 4.7. So my vertice, or my foci in this case, is going to be about right there and about right there. Okay, so how do we graph these now? So in order to graph these, what we are going to actually do is we're actually going to create kind of a rectangle using our vertices and our co-vertices to do this. So what we're going to do is I've got my vertice line. What I'm going to do is I'm just going to create a horizontal line, nice horizontal line. I'm going to create a horizontal line through each of the vertices, each of the two vertices. So we're going to draw a nice horizontal line. So there's a horizontal line. There's a horizontal line to the vertices. And this is going to actually help us find our asymptote. Now we're going to draw a horizontal line through the co-vertices. So now our important parts here are these corners here, 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 and here. Those are kind of, and those are going to help us write our asymptote. Okay, so our asymptote is going to be y is equal to plus or minus. So it is a vertical one, so it's going to be a over b. But if you think about this, it's rise over run. So essentially we're going to draw, our asymptote line is actually going to be the line that goes through, oops, let's see what I want to do here. The color is not the button I want to hit. I want to hit this. Our asymptote line is actually going to be the line that goes through those two corners and through our center. So that's one of our asymptote lines. Our other asymptote line is that one right there, and I'm going to fix it because it's like way off. Now I've moved my graph, which hasn't helped. Okay, so those are my two asymptote lines. So my asymptote lines are going to go through the center, and they're going to kind of go by those intersection points on those corners. And those are going to be my asymptote lines. So we want to write the equations of these asymptote lines. And if you think about equations of lines, y is equal to mx plus b, so it's the slope, so it's up and over. Well, in this case, that's my a value. That's over is my b value. So we're going up 2 over 4. So it's up 2, should get my pen back, up 2 over 4 times x, and then it's mx plus b, so it's our intersection point. Well, we're at 0, 0, so we're just going to leave it there. So we can say our asymptote lines are plus or minus 1/2 x. So those are our asymptote lines. Now we're going to use those asymptote lines to graph this hyperbola. So what then is going to happen with this is our graph is going to follow that asymptote line down. It's going to go through the vertex, and it's going to bounce up and kind of follow that laugh down like that. And it's going to go here, here, and approach those lines. Mine is kind of iffy with the drawing, but that is kind of what my hyperbola is going to look like. And with all of this drawing, the actual hyperbola is just this, what I'm highlighting in blue. All the rest of it is there is just to help us draw these. Okay, so we can find the center pretty easily. We can find the a values, we can find the b values. We can find the c value, that's at focus. We need that asymptote line in order to help us graph it. And then we can find those asymptote lines equations as well. And this is kind of what you're going to be expected to do with these. So let's look at another example. Okay, so we've got y squared over 9 minus x squared over, x squared over 9 minus y squared over 4 equals 1. So there's a minus in there, so we know that it's going to be an ellipse, which is a good thing. So we can start out by finding the center. The center with this one's going to be the same. It's just going to be 0, 0. So I'm going to put a dot at 0, just helping me. My x value is changing by 9, and the x comes first, so that's going to be my a value. So a squared equals 9. So a is equal to plus or minus 3. So I'm just going to go ahead and put my dots at plus and minus 3 from there. My b squared value is 4, so b is equal to plus or minus 2. So I'm going to go plus or minus 2 from my center point. I'm going to go ahead and find my focus. So c squared is equal to a squared, which we know what a squared is. It's 9. B squared is 4. So c squared equals the square root of 13, plus or minus the square root of 13. And that's going to be good enough, but just for general purposes, so we can look at kind of where that would be a little bit, so we just kind of get an idea of where that focus is going to be. That is 3.6. Now x comes first, so these are going to open out from each other. So my focus line, my focus is going to be about 3.6. So on the graph, it's about there and about right there. Okay, so now I'm going to create my box because I'm going to help myself draw this. Okay, again, it kind of helps me draw the asymptote lines. So I'm going to draw a horizontal line through, in this case would be my co-vertices, and I'm going to draw vertical lines through my vertices. So those are those. Now I'm going to take and go ahead and draw a line that goes from corner through the center and out the other side, and these are going to be my asymptote lines. Okay, so there's my other asymptote line. It's off a little bit, so I'll try to fix that a little bit. Of course, I'm moving everything else again. So there's my asymptote lines. So I can go ahead and write my equation for the asymptote line. It's y is equal to a plus or minus, and again, I'm just going to do rise over run. In this case, it's rising up 2 and running over 3. And by definition, it's b over a times x. So my b value is 2. My a value is 3. So 2/3 x, it goes, our y-intercept is 0. So there's our asymptote line. So we've got everything in there that we need now. So now we have to draw it. So this is an x equal, so it's going to look like an x. And I'm going to use a highlighter, it's a little bit easier to see. So it's going to come down through here, it's going to go through the vertex, and then follow this asymptote line out. And then it's going to come down this direction through the vertices and follow that asymptote line out. And there it is. Okay. Anyway, we found everything that we want. We want to find all these different things, and we're good there. Okay, so now let's add a different center into there. Okay, so our center in this case isn't going to be 0, 0, and how does it change up when we do that? So start with looking at it. Again, there's a minus symbol in there. Our x comes first, so it goes out in that direction. So center-wise, we're in good shape. It's the opposite, so it's going to be negative 1, 1. There's our center. So negative 1, 1 is right there. My a squared value is equal to 4, so a is equal to 2. So that means from my center, plus or minus 2, sorry. That means from my center, I'm going to go 2 to the left, and I'm going to go 2 to the left and 2 to the right. And it's an x, so that's going to go this direction, so it's underneath my x. So I can put a dot there, and I can put a dot there. Those are along my transverse. My b squared is equal to 16. So b is equal to plus or minus 4. So my y value is changing by 4. So here's my center. I'm going to make that center a different color. Let's make it blue. So there's my center. Everything goes from there, so I got to go 4. Let's go back to pink. 1, 2, 3, 4. Nice thing about having a graph is I can use the graph. 1, 2, 3, 4. Okay, so those are my co-vertices, so to say. So c squared is going to be a squared plus b squared, so 4 plus 16. So we've got this square root of 20 again. So c is equal to plus or minus 2 times the square root of 5. Okay. So 2 times the square root of 5. And again, we're going to x, so if we would need to go 2 times the square root of 5 away from our center. So 2 square root of 5 was 3.6, I think. 4.7. So we're going to go 4.7. So there's 1, 2, 3, 4. So it's about 5 units away. So there's 1, 2, 3, 4, 5. So it's about there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's about there and there. And don't even need to really put those there. We're just going to find that C value. Okay, so the next thing we're going to do then is we're going to go ahead and, just to help us draw this, we're going to put in our line. We're going to go ahead and put our vertical and horizontal lines so we can find our corners. So I'm not going to make it as long this time. Just make it as long as I need. Okay, so there is my corners. So that helps me then draw my asymptote lines, and it's a little bit obviously steeper asymptote line this time. So it goes like that and like that. Okay, so we're just going to do the general part of it. We're not going to worry about the y-intercept so much with this. We'll be happy with just saying y is equal to plus or minus. So this is going to be an x, so it's going to be b over a. So my b value is 4, my a value is 2. So 4 over 2 times x, so plus or minus 2x. We're not going to worry about finding the y-intercept, technically speaking. Technically speaking, there's a plus something right here. We're not going to worry about that plus something right now. Let's just worry about and focus on that part. If you want to find that, something we've done in a previous lesson, but that's not really the point of this piece of it. So now we graph it. It looks like an X, so this goes like this and then down like that. And then from here down through there and like that. Okay. So about 20 minutes into the lesson right now. It's getting a little lengthy. I'm going to have you do one, press pause. I'm going to have you do this one. Press pause, take a break. If you want to do the first few in the assignment, go ahead and do the first few in the assignment. I'm going to stop the assignment. I'm going to stop this video at this point. I would stop and do the first 3 or 4 problems for your assignment today, the ones that follow this method. And then you can come back and watch part 2 of the video after you do that. But I'm going to put this one up there. I want you to go through it real quick and press pause. When you're done, press play, and the rest of it will be there. And then again, I would suggest that you be done, do the first part of your assignment, come back and do the second part of the video a little bit later. Get away from math for just a little bit. If you're in class, sorry, you get both parts. Okay, so there's that one. You'll be a little bit careful with it because that y comes first. So make sure when you're dealing with your center, make sure you put the k second and the h first. So that's why it's 1, -1, because the x has to go with the x and the y has to go with the y. And those are the different types of things you'll be asked to do within those questions. So I get going on this first part of your assignment. Just take care of the ones that look like that and then come back and then we'll do part 2 that's going to be in conic form.